In this video, we are going to talk about the examples of limit of trigonometric function. So example is evaluate limit x tends to 0, 1 over x cotangent square. So what I'm going to do, I'm going to consider this limit. So my limit is limit x tends to 0, right? 1 over x cotangent square x, right? Now we all know that cotangent is basically what? Cotangent of x is basically 1 over tangent, right? So if I'm finding the square of cotangent, then cotangent square will be what? 1 over tangent square. So let's substitute cotangent square x as 1 over tangent square over here on this expression. And if we do that, we will write this one as limit x tends to 0, 1 over x times 1 over tangent square x, right? Now this x is basically what? X over 1. So I can multiply x times 1 and then 1 can be multiplied by tangent square. So if I further simplify, I will get this one as, this is my formula that I use, so I will keep that in mind. So let's further simplify, and if I do that, I will write limit x tends to 0. I have 1 over x divided by tangent square x, right? And the reason why, because x times 1 is x and 1 times tangent square is tangent square, right? Now let's simplify further. So as you can see, I have x over tangent square at the denominator. If I simplify further, I can flip this one and I can write this one as limit x tends to 0, and I will have tangent square x over x, right? Now we have a formula for the limit of the tangent function, and if you remember, the limit of tangent function is what? Limit x tends to 0, tangent x over x is equal to 1, right? If you look closely at this function, I have tangent square x over x. So basically, in order to use this formula, what I need to do, I need to multiply numerator and denominator by x, right? So I'm multiplying numerator and denominator by x, and if I do that, what will happen? I will write my limit as limit x tends to 0. I have tangent square x, right, over x times x is x squared, and my this term at the numerator will be what? Times x over 1, right? Let's further simplify, and if I do that, what will I write? I will write this one as limit x tends to 0. I have tangent square x over x square can be written as tangent x over x, right, whole square, right? And then I need to take the limit with x too, so I will write times limit x tends to 0 x over 1, right? Now what did I do? I just simplified tangent square x over x squared as tangent over x whole square, because if I simplify this square, the whole square term, I will basically get this term, right? So basically, when I did that, I'm taking the limit inside with tangent x over x function and x function, because I'm separating the limit with the first term right here and the second term which is right here, right? Now, let's use this formula to find the limit of first term, and if I do that, what will I get? I will get the first term as what? 1 squared, because this whole thing is 1, so I have 1 squared times, I'm substituting the limit of 0. So what did I get? 1 squared is 1 times 0, and 1 times 0 is what? 0. So The limit for this function is basically what? 0. And this is basically my limit for this given function, right? Okay, now let's consider another example. So my another example is evaluate limit x tends to 0 sine 5x over sine 3x, right? Now, if you remember the formula for the limit of sine function, the formula was limit x tends to 0, right? Sine x over x is what? 1, right? So what I'm going to do, I'm going to separate the numerator and denominator, and I will try to write this expression, or I should say this function, as this. So I'm going to separate, so I will write limit x tends to 0 sine 5x over 1 inside one bracket, and then I'm separating the denominator, so I will write this one as my second term, which is what? Limit x tends to 0 1 over sine 3x, right? Now, if you remember, the formula had the same value for x, or I should say, I have the same x at numerator and denominator. So I have only one x over here at the denominator, right here, and the same x is with the angle. But over here I have 5x, but I don't have anything here. So what can I do? I can get 5x over here, right, somehow, and I can get 3x over here somehow, and then only I can use the formula. So how do I get it? So one way I can think of, if I multiply this one by 5x and divide by 5x, and 3x over here, multiply and divide by 3x, then I can have 5x over here and 3x over there. So that's what I'm going to do. So what I'm going to do, I'm going to rewrite this expression as what? Limit x tends to 0, I will write sine 5x, and I will divide by 5x, and at the same time I'm going to multiply by 5x, right? This is my first term in the limit, right? And the same way, I want to convert this one in this form, so I'm going to write limit x tends to 0, right? And I will write 3x, because I have 3x over here with the angle of sine, so I will write 3x over sine 3x. So as you can see, I'm considering 3x, which is basically what? I'm multiplying the numerator by 3x, so I should divide by 3x too, right? So basically, what did I do? I multiplied 3x over here with the second term, then I did divide by 3x. And in the same way, I divide this expression by 5x, so I multiplied the expression by 5x. So basically, in a way, I did not change the overall value of the expression, right? So, as you can see, when I divide 5x by 3x, I can easily cancel my x out, right? So, let's simplify and rewrite this expression. And if I do that, I will write this one as limit x tends to 0. I have sine 5x over 5x, right? Times what I have, 5 over 3, because x is cancelled out from numerator and denominator. And the second term that I have is what? Limit x tends to 0. I have 1 over sine 3x over 3x. Because if I flip this term, 3x over sine 3x, I can write that one as 1 over sine 3x over 3x, because if you flip it, you will get the same value I have over here. So basically this term right here is same as this term over here. And you can do the mathematical expression, to just simplify, or I should say you should pause the video and simplify this expression, the second one, this one, to see if you can get that term or not, right? All right, so I'm going to move on. So if we use this formula for the sine x over x, what will I get for this first term? That will be my 1 times, I have 5 over 3, so I will write 1 times 5 over 3 times, this one is also, as you can see, 1 over sine x tends to 0, sine 3x over 3x, that is also 1. So I have 1 over 1. If I simplify whole thing all together, what will I get? 1 times 5 over 3 times 1 is basically what? 5 over 3. So basically, the limit for this function I got is 5 over 3. So what is the value of this limit? The value of this limit is basically what? 5 over 3 for this limit, right? And this is how we will evaluate our trigonometric function for the limits.